Okay, we're covering 2 lessons today. So, buckle up, pretty sweet. 8.4 is angles of elevation and depression. 8.5 is law of sines. We'll start with 8.4. An angle of elevation is the angle formed when a line raises above horizontal. So think about, here's you with a big ear looking horizontal. As you rotate your head up to look up, that's called the angle of elevation. Angle of elevation is always from horizontal, so it can't ever be like this. This can't be an angle of elevation. It has to be this, from horizontal. Angle of depression is just how you look down instead of up. Angle of depression is the angle formed when a line drops below horizontal. But angle of elevation and depression are always based on where is horizontal. So here's your typical angle of elevation and depression type problem. An air traffic control controller, tower control guy, or gal, I don't know, could be either, sees an incoming plane, not a place, but a plane, at an angle of elevation of 23 degrees. The plane indicates that its elevation is 20,000 feet. Part A, at what angle of depression does the plane see the tower? And part B, at how far is the plane from the tower? I want you to pause the video, draw a sketch, and try to answer those 2 questions. Actually do that now. There's my tower. I'm really good at drawing planes. Planes are my thing. Where's a big old jet plane? Okay, the angle of elevation is always going to be from horizontal. So start with the horizontal line. From here to here was 23 degrees. The first question was, what's the angle of depression? The plane sees the tower. Well, for the plane, horizontal is right here. Thought that was a line. For the plane, horizontal is right here. So their angle of depression is going to be this angle right here. Well, how do we find that? Well, these 2 lines are parallel. They're both horizontals, they're parallel, which means that these 2 angles are alternate interiors. This is also 23 degrees. Now the question we ask next is, how far is the plane from the tower? Well, I'm going to draw a triangle. We're not going to worry about the fact the tower is a little bit above the ground. We're just going to say the plane is 20,000 feet in the air. We know that this angle here is 23 degrees, and we're not going to worry about the fact that this is a little bit above the ground because 20,000 is so high it doesn't really matter. When we ask how far is the plane from the from the tower, this is our plane out here, and this is our tower right here. We could be trying to find this length here, or we could be trying to find this length here. They're both pretty reasonable. Usually with planes, you would actually be trying to find this length because you're worried about the horizontal distance it has to go. The change of elevation isn't going to be that big of a difference for the time it takes. You're usually trying to figure just how far out are you from your destination. So we're going to find value of A. If you found C, that's reasonable, but you're looking for A typically. Well, I've got this side and this side I want to work with. That's opposite and adjacent. I'm going to be using tangent. I know the tangent of 23 is 20,000 over A. So that means that A equals 20,000 divided by the tangent of 23. Again, you use tangent a lot because you typically are working with opposites and adjacents. $47,000 feet. That's a kind of silly way to represent that, though. So let's divide that by 5,280, because that's how many feet are in a mile. And it's 8.9 miles. So going to be there very soon. This plane planes go really fast. It's like, seconds or minutes away. That's angle of elevation depression. Here's the angle of elevation. Here's the angle of depression. That's the whole game. Okay, next, law of sines. This is going to be the first half of section 8.5. The second half will come in the next video. So SOHCAHTOA only works in right triangles. For non-right triangles, we have to have other ways to solve a triangle. Like here is a non-right triangle. If I wanted to, I could make it two right triangles. Right? Here's a right triangle and here's a right triangle. If I just drop that height, that altitude, this triangle over here would be pretty easy to solve. We could find this angle, we could find this angle. But we wouldn't have really, we could then find this length. Once we found that length and we knew this angle, we don't have any way of finding this angle or this angle, which means we can't solve the triangle yet. So even dropping a height poses some problems. So there's a new tool, it's called the law of sines. The law of sines looks like this. Sine of A over A equals sine of B over B, which equals sine of C over C. You will pretty much never see all three written at once. We pretty much just write sine of A over A equals sine of B over B. But here's the point, okay? The letters themselves don't matter. Like if I called this triangle DEF, don't think, well gosh, what's A and what's B? Where'd my A and B go? What matters is you need an angle-side pair. The law of sines only works if you have an angle-side pair. Here's what that means. I know the value of this angle, and I know the value of its opposite corresponding side. So that is my angle-side pair. They have to be values that you know. They can't be variables. They can't just be letters that you have written down. You have to know the actual value of those angles and sides. Once you have your angle-side pair, setting up the law of sines is pretty simple. I'm just going to do sine of 17 over 40. I guess I'm going to call this A. It doesn't really matter. This will be A and A. Equals the sine of B over 32. I'll call this angle B, which makes this side B, because the angles and sides are always opposite when they correspond. Now I'm going to solve for this angle right here. Well, I multiply both sides by 32. This is now a proportion. I can solve the proportion by cross-multiplying. So you can think of this as becoming 40 sine B equals 32 times the sine of 17. I'm trying to get this B by itself. That is my goal. Isolate that variable. So next, divide both sides by 40. That becomes the sine of B equals 32 sine 17 over 40. Finally, to get rid of that sine, I have to use sine inverse. The sine inverse undoes the sine. It's how you cancel out a sine. You do a sine inverse. So we're going to have B equals the sine inverse of 32 sine 17 divided by 40. You could have calculated things along the way if you wanted to. Like you could have found the sine of 17 times 32 and then divided that by 40. You can do it all in steps if you want. I prefer typing it in once at the end. 32 sine 17, close parenthesis, divided by 40, close parenthesis, 13.5. This angle right here is 13.5 degrees. Okay, so a lot happened there. I'm going to keep solving this triangle in a second, but I want to just kind of recap. I had an angle side pair, so I had to work with another angle side pair. I used this one right here because I knew at least one value. I knew at least the value of side B. So I set up the law of sines, and the variable was inside this sine function. Sine of B is what was happening here. So to find the angle, I use inverse sines. We always use inverse sines to find angles. So cross multiply, divide when you have to, you got it. Okay, I can keep going on this triangle. Now that I know that this is 13.5, 17 plus 13.5 is 30.5. all of the angles of a triangle have to add up to 180. So 180 minus 30.5 is 149.5. This angle here is 149.5 degrees. I need to find this side. I'm going to use the law of sines again. This is still the angle side pair I want to start with. Always use the same angle side pair. Always use the angle side pair you were given because you know it's true and because it wasn't rounded. There was some rounding that happened here which could make my calculations more incorrect as I keep going. So always use the angle side pair you were given. So I know the sine of 17 over 40 equals the sine of angle C, and angle C I know its value, it's 149.5 over side C. Solve that for side C, so first I cross multiply. I divide both sides by sine 17. And I calculate. 40 times the sine of 149.5, close parenthesis, divided by the sine of 17, close parenthesis, 69.4. So this length C is 69.4 feet. So we just solved a non-right triangle given three things. As long as one of those things involves an angle side pair, you're set. Okay, take a second and try to solve at least one of these. I don't care which one. If you want to be real bold, do both. That's probably best, do both. But maybe do one, watch the video, pause, do the other. But right now, pause, solve this triangle. Solve means find all the missing sides and all the missing angles. Again, I don't really care what's A and B. I'm just going to match up angle side pairs. So I'm going to do the sine of 51 over 99 equals the sine of B over 82. I'm just going to call this angle B. I'm going to solve for this B. Well, it's going to end up being this times this divided by this. I could do the cross multiplying, but I can start kind of do the cross multiplying in my head, or even just think I don't have to cross multiply. I can just multiply both sides by 82. So really I have 82 times the sine of 51 over 99 equals the sine of B. Now here's the part that you're going to forget because this part's kind of new and kind of weird, but you take a sine inverse of both sides. The sine inverse of 82 sine 51 over 99 equals the sine inverse of the sine of B, and these two things cancel each other. So I'm going to calculate all of this, and that's what my angle B is. Make sure you close parentheses as you need to. I'm just going to call it 40. Well, we'll do 40.1. Angle B is, let's just do 40. Angle B is 40 degrees. That means that this one up here is 89. Okay, let's find side C. I'll go in pink. I'm going to do my same angle side pair, so the sine of 51 over 99 equals the sine of 89 over C. So this is going to be, I'm trying to find this, so it's going to be this times this divided by this. If you've learned how to, like, your proportion shortcuts, that's it. If you want to cross multiply, that's fine. But if you want to think about the fact I'm getting this C by itself, I take the thing above or below it, multiply it diagonally, and then divide by the thing that's left. But I'll write out the cross multiply. It's C times the sine of 51 equals 99 sine 89. Divide both sides by the sine of 51. And there's side C. (99) sine 89 divided by the sine of 51. 127.4. That's how many units long side C is. Okay, one more. Let's do the triangle on the right. Carve out some space. It's going to take me forever. We can find this angle here right off the bat. 180 minus 110 minus 14.3 is 70 minus 14.3, which is 60, 55.7. That angle there is 55.7. Piece of cake. Here is my angle side pair. So I'm going to do the sine of 110 over 6.2. And if you want to put the sides on top, you can. Like I know it says sine of A over A, but you could make it A over sine A. You could do 6.2 over the sine of 110 equals, let's find this side first. We'll call it C. 14.3 over X, or 14.3 over, putting the angles on top, on the bottom this time. So sine of 14.3 over side C. Doesn't really matter. If you want to flip this and flip this, you can. Whatever you prefer. The nice thing about this is the C is on top now. So I just multiply both sides by the sine of 14.3. And I'm going to get my side. .63. 1.63 miles. Okay, finally, let's find this side over here. I'm going to call it B. So here's triangle ABC. Let's find side B. It's going to be the same thing. I'm going to do sine on top this time. So the sine of 55.7 over B equals the sine of 110 over 6.2. Always use the side you were given whenever possible. So it's going to be this times this divided by this. I've written this out enough. I'm not going to spend any more time on that. Sine of 55.7 times 6.2 divided by the sine of 110 means that this final side is 5.45 miles. Now here's a good check. The biggest angle should go to the biggest distance. The smallest angle should go to the smallest distance. That's what's happening, so that's a good sign things are okay. There it is. Law of sines can be used in any triangle with an angle side pair. That includes right triangles. You could use law of sines in a right triangle if you wanted to. So angle, 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 side, 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 and side, angle, side are the three that cannot solve. Okay? If you don't have an angle side pair, you can't use law of sines. So you can't do side, 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 and you can't do side, angle, side. There's no angle side pairs there. It's also completely impossible to ever solve an angle, angle, angle. There's no way to solve angle, angle triangles. Angle, angle, angle triangles. But next video, we'll learn how to solve SAS and S using the law of cosines. Also, don't forget, angle of elevation goes up, depression goes down. We're done.